Welcome to our final project presentation for CSS332 Microcontroller and Applications. Today we are excited to be talking about our project, Smartroom. Smartroom is our adaptive security and climate display system, which we designed to be educational, practical, and applicable to real situations. So first off, let's talk about the project overview. The purpose of the project is to improve room safety and environmental awareness. We did so by detecting intruders, having security access with a keypad, and temperature display using two 7-segment displays. From a technical viewpoint, our project features keypad-based security system, motion detection, and alarm buzzer, and a multiplex temperature display system. The project focuses on combining sensor input and visual output and sound feedback into one integrated system. The key functionalities of our project include the keypad, like I said, for security system that allows the user to arm or disarm the lock. The user will be given 4 attempts to enter the correct passcode. Failing to do so will sound the alarm. After the alarm is sound because of the incorrect attempts, the only way to shut off the alarm or disarm the alarm is to enter the correct code. The next function is the intruder detection system. We use a ultrasonic sensor which will buzz if there's an object within 100 centimeters or 1 meter of the sensor. And the last function is the temperature display, using the DHT11 sensor or the temperature and humidity sensor to detect and display using two 7-segment displays. Next, let's move on to the circuit. On the slide, there's a list of the components used. All of these were provided to us by SIT for our lab activities. As for how we connected it together, we have displayed a system diagram. On the right is the diagram from Tinkercad, and on the left is a hand-drawn circuit diagram. So as shown on the screen, 7 pins from the keypad are connected to the pins A0, A1 all the way to D0. We skip the last pin of the keypad because we didn't use the last column of the keypad. We did so to minimize the pin usage. For the display system, we connected both 7-segment displays to D2 and D8 and had the COM pin of both displays connect to different Arduino pins. We used this as the control pin, and in this case, we connected it to D1 and D9. Next are the sensors. The first one is the temperature sensor, the DHT11. We connected it to D10. Next is the ultrasonic sensor, which we connected to D11 and D12 for the trick and echo trick pins. And lastly is the buzzer for the sound. We connected it to the D13 pin.
Now let me explain how we implemented the multiplexing concept in our project. Instead of using 14 separated pins to display the 7 segments, we use only 7 pins for displaying numbers, and we have 2 pins for controlling which one will display. We turn on the control digits at only one at a time, and then we quickly switch to turn on the other one. Then if the action is fast enough, which is 5 millisecond delay, it will appear simultaneously. Before going to the code overview, let's look at demonstration video first to understand how the flow works.
Okay, so this is gonna be our demonstration video. In the starting state, there's gonna be the temperature showing all the time, and the ultrasonic is detecting, but there's not any sound buzzing because we haven't enabled it. To enable it, we need to press the 0 3 times, but before that, we are gonna enter the code. The correct code is gonna be 1, 2, 3, and 4. But like we have said for the functions, if we enter the code incorrectly 4 times, then that's gonna be a continuing buzzing sound. So 1, 2, 3, and then 4. We press the square. This is gonna be the correct code. Nothing is gonna happen. But if we press 1, 2, 3, 4, then press something wrong again, that's gonna be we have already input the incorrect password 3 times, so this is gonna be the last time. Doing so, we get the continuing buzzing sound, which we can only stop by pressing the correct code 1, 2, 3, 4. After we have done that, right now the buzzing isn't gonna be automatic, and we can start the automatic part by pressing 0 4 times. Right now the ultrasonic is gonna detect, and then the buzzer is gonna sound automatically when there's an object in 100 centimeters from the sensor, like this. My hand's in 100 centimeters from the sensor, so that's a buzzing sound. As for the temperature function, we have a DHT11 right there detecting the temperature, and right here is the displaying temperature. Right now the room temperature is around 0.10 degrees Celsius, so we display 2 and 2. So this is the serial monitor for when we press the code. Like before, we will be entering the correct code first, 1, 2, 3, and then 4. Pressing square is entering. As we can see, the serial monitor shows unlock. Then if we press the wrong code, for example 2222 square, that's gonna show how many chances we have left. 3, 2, 5 something. It doesn't necessarily need to be 4 digits. Just pressing 1 like this is okay too. As for the input, and once we press square, the buzzer is gonna sound. We can now enter the correct one to stop, and entering 0000 will enter the automatic censoring mode. Now the alarm is enabled and will be sound when something enters the radius.
Let me explain. The first part is pin setup. The pin setup, we set up input pin and output pin. Also the keypad setup. And let me explain the global variable for the boolean. The first one is intruder arm. Intruder arm is set initially to be true, which is it will detect any objects or motion in front of the ultrasonic. The next one is set alarm, is initially set to be false. This one is when you input the wrong password for 4 times, it will set alarm to be true, and it will not turn off until you input the correct password. The next one is this alarm. This alarm is initially set to be true. This one is we use for disable the alarm that detect any objects or motions in front of ultrasonic. If we turn off this one, it will the buzzer will make a sound every time there is a object or motion. For the next part is temperature. The temperature measurement is we detect the temperature via DHT11 and we display it in digits, which I have already explained in multiplexing concept. For the next one is intruder detector or the sound system. We measure distance via ultrasonic device. The concept of ultrasonic is we send the signal of high and low, and we record the time that the signal come back from echo. Then we convert the time duration into distance. Then if the distance is between 0 and 100 centimeters, we will turn off the buzzer or the sound device. Otherwise, it will be turned off. And also, the buzzer or sound device is active low. If we want to turn it off, we have to put it high, and if we want to turn it on, we have to put it into low. For the next part is keypad system. The keypad system is receive input from keypad, and user can enter numbers from 0 to 9, and when they press the square or hashtag symbol, it will be the input will be entered to the system, and if the password is not matched with the input, the user has only 3 chances left to input the right key, and if they cannot, the alarm will be set, and it will not be turned off until they enter the correct code, and the user can press star to clear or delete the input. Also, if they want to toggle the auto alarm detection, they can put 4 zeros to toggle it. With all technical parts of this project, we would like to give credit where it is due, and we would like to thank our instructor and everyone that supported us, and special thanks to our senior from the last year that did the project of door lock, which inspired us to build our project. We also had ChatGPT to help us with error fixing and cleanup. Like I said before, this project got inspired from our senior, but we increased the security feature with motion sensor and advanced keypad usage. Also, we added some temperature measurement and multiplex display system. Thank you for watching our Smartroom project. I hope that you will find this project informative and inspiring. Thank you.